Okay, so now we are going to solve a problem let's assume we have a main memory of 64 MB. 64, the size of the memory is 64 MB. The cache line size is 64 bytes. So it means that since the cache line size and the memory block size are same, so we also have the cache line size of 64 bytes. So what is the main memory block size?
64 bytes.
Main memory block size is also 64 bytes. Why it is this? Because the size of the main memory block is equal to the size of the cache line. So it is actually at the granularity at which we are storing the block at the cache. Okay. So now we have a cache of 512 KB, 512 kilobyte. The size of the cache is 512 kilobyte. Now we need to find the format of the main memory address. So now we need to find the format of the main memory address for direct map cache and direct map cache. Then 8-way associative cache and then 32-way associative cache. So to solve this problem, first we need to find the number of bits required for the main memory. Okay, so first we need to find the size, the number of bits, the number of address lines. First we need to find the number of address lines. Okay, so if we need to find the number of memory address lines, so actually if we see that now we have 64 MB of memory, and now let's say we assume that it is now arranged at the granularity of a byte. So can we write it like this? 2 to the power A cross W. Okay, so 2 to the power A cross, what is W?
8.
8 bits. Because it's bits. Because bytes. Okay, so now can we write it like this? 2 to the power 6, 2 to the power 20, 2 to the power 6 is 64, 2 to the power 20 is for megabyte, and multiply by byte, so it is 8. So 8 will what?
Cancel out.
Cancel out. Okay, so what is now A?
26.
66 bits. Actually, this is a byte addressable. So this is a byte addressable address.
So this is the reason we have chosen W equals to 8.
Yes. Now if you do it at a word level, so the address will change. So now if you divide this into different format, now we have 3 fields. If you remember, there were 3 fields. One was the offset field. What does the offset field determine? Offset fields identifies a byte within the block. A byte
Within a
the
word.
offset. So we call it as a byte offset. And then we identify an index field. It identifies the set within a cache, and then
Take.
a tag field. The tag field is used to identify a block within a cache set to determine whether it is a hit or a miss. So now these are the 3 fields. So actually I can write it very. So it means that this identifies what? A block, a byte
In a block.
within a block. And what does this field identifies?
Set.
Identifies a set, whether it will go to set 0 or set 1 or set 2 or so on. And identify a set within a cache. And the tag field is used for comparison. So why it is needed? To identify whether it will be a hit or a
Miss.
So actually if the tag field matches, now there are 2 things. If the tag field of the address matches with the stored tag field, if the tag field of the address matches with the stored tag field within a cache set, and the valid bit is 1,
Then it will be a hit.
then it will be a hit. So fair comparison to identify a hit or a miss. So we will further elaborate it like this. So we need to identify that whether a block exists within that set or not. So it means if we further elaborate it, so it means, so can we write it like this? It is used that if the tag field matches, if the tag, there are two, if the tag field of the address, if the tag field of the address matches with one of the stored tag field, one of the stored tag field. If you remember from a set perspective, so let's assume we have n, let's assume this block is mapped to set I. The block is now mapped to be set I. Who will identify that it is mapped to set I? Which field?
Index.
Index field. So the index field, in the index field I will be stored. If it's I is 0, what does it imply?
0,
It is mapped to set 0. If I is 1, it is mapped to set 1. So what is I? What is the range of I? So can we write it like this? I. So can we write it like this? 0 is smaller or equal to I. 0 is smaller or equal to I is smaller or equal to number of
2 की power is
sets minus 1. Number of sets minus 1.
yes sir.
If the number of sets are 64, it will range from 0 to 63. And number of sets varies. Number of sets varies. If it is a direct mapped cache, so number of sets will be more or less?
More.
More. Because in the direct mapped cache store one line. Two-way associative cache store
2 lines.
2 lines. So it means number of sets will be reduced. I already. Okay. So it means, so it will stand for 0 to smaller or I and I. Who will determine this I? Who will determine this I? Which field of the address? To which I is mapped?
Index.
The index field of the main memory block address will identify that particular set. Okay. Now byte offset. So byte offset. Now in this particular example, how many bits will be required to identify a byte within the block?
6.
6. Why 6?
64 bytes का.
Because so the byte offset field. So the byte offset field is equal to log 2 of what?
Cache line size or memory block
No,
size.
number of bytes within a block or cache line. So what is, how many number of bytes are within the block?
64.
64. So it is equal to log 2. 2 is for 6. So it will be equal to 6 log 2 of 2. If you look at this, it will cancel out, it will be equal to 6. So it means that now we have fixed one thing. And this is same for all. This is same for all. This is same for all. Okay, now if you look at here, how many bits? This will be same. This format will be same for direct map cache, for 8-way associative cache and a 32. What will be different?
Index और tag.
The index and the tag field. Why index field will be different?
Associativity change हो रही है.
Because associativity is changed. When associativity is changed, the number of sets are changing. The number of sets are changing. So if you look at this byte of set field, so now this is now how many bytes? Bits.
6 bits.
And the remaining bits, if you look at the remaining bits from tag and the index field, the remaining bits are okay. Total, how many total bits are there? 26 bits. So these are 26 bits. How many bits are there?
Total 26 bits or 6 bits? It's 20 bits.
20 bits. So if you look at 20 bits, now we need to find the number of blocks. Okay, actually if you look at it, can we say it like this? How many bytes are stored in memory? How many bytes you can store in memory? It's very simple from here. How many bytes you can store in memory?
64 megabytes.
No.
In
How many
memory?
bytes? Total number of bytes you can store in the overall memory. Now, if you look at the memory, so now we have a memory.
64 bytes in number of blocks.
No. It's evident from this here. I can directly give you an answer. From the information is given. How many bytes you can store in memory? You can store 2 to the power 26 bytes.
That is 64 megabytes.
Because to make it 64 megabytes, actually 2 to the power 26 bytes. So actually, if you look at the memory, can I rub it off?
Yes.
Okay, so I'm now rubbing it off if you want to. So actually, this is no confusion with this. No confusion. So I'm now rubbing it off. Maybe I can do it. Maybe I can draw it here. So if you look at her memory, so now this is our memory view. This is the memory map. So can we write it like this? Memory block 0. Main memory block 0. So can we write it like this? Byte 0, byte 1, byte what?
63.
Byte. Then after that, what will be the memory block?
MB2,
MB1.
MB1, yes.
Memory block 0, memory block 1, and so forth, so on. Okay, so if you calculate the total number of blocks, okay, so the total number of bytes is equal to 2 to the power 26. The total number of bytes. Okay, how can you calculate the total number of bytes? So total number of bytes is equal to total number of memory blocks, total number of main memory blocks multiplied by block size. Now we need to find, okay, now just give me an answer from this information. How many total number of memory blocks? How many number of total memory blocks you can store in memory from this information? It's very evident. How many total number of memory blocks? From this information. Now this has been removed. How many bits are left? 20. So how many blocks you can store?
2 to the power 20.
2 is power 20. So the total number of memory blocks. So total number of memory blocks are 2 is power 20. Multiplied by what? Block size? 2 is power 6. What is the total number of bytes? 2 is power 26. Okay, now we can do it in another way. How many total number of blocks? We can also do total number of main memory blocks. Can we write it like this? Memory size divided by block size. What is the memory size?
64 MB.
What is the block size?
64 bytes.
64 byte. Can we write it like this? 2 to the power 6, 2 to the power 20 in byte divided by 2 to the power 6 and byte. Byte will what?
Cancel out.
Cancel out. 2 to the power 6 and 2 to the power 6 will cancel out. So how many number of memory blocks are there?
20.
Now, if you look at this, so this, okay, now can we write like this? So actually, what is MB0, MB1, and then MB and number of blocks minus 1. So now if we say there is a parameter index, that is in the previous case it was I, now it is J. So can we write it like this? 0 is smaller than J or smaller or equal to MB, not J, NB minus 1. What is NB? What is NB? What is NB?
2 to the power 20.
NB. NB stands for
Number of blocks.
number of the total number of blocks
In the memory.
in the memory, and it stands for from 0 to MB to the power 1. So actually, if you look at here, so actually it will be equal to MB. Okay, what is the total number of main memory blocks?
2 की power 20 minus
So
2.
to MB to the power 20
minus 1.
You can store these number of main memory block, these number of blocks in
Main memory.
memory. And what is J? J identifies the memory block number. Okay, now J will be determined by which field of the memory address? Not
Tag
tag.
and index.
Tag plus index.
Index.
Because it is 20. If you look at this, 20 bits are required. So actually, this will require tag plus what?
Index.
Tag plus
Index.
index field. So now this is equal to tag plus index field. Now we are only now looking from the memory side. We are not looking from the cache side. Now we have to identify now how many number of sets are required for direct map cache, how many number of sets are required for 8-way associative cache, and how many number of sets are required for 32-way cache. Okay, sure. Can you take a, you may take a screenshot of this, or enough? You may take a screenshot. Okay, now it's recorded. Okay. Now I am rubbing it off, and now I move further. Actually, this is understood or not?
Yes, sir.
Understood? Okay. I am now rubbing it off. And now I will explain it furthermore. Now I will explain it furthermore. The same thing will be explained in furthermore. Okay. Now there is a simple formula. How many number of sets? How many number? Okay. Now we need to identify the number of cache lines. The number of cache lines. Okay. Let it denote it by parameter L. And L, NCL. Okay. NCL, number of blocks, number of cache lines within the cache. How many number of cache lines we can store in the cache? So it's some formula is simple. Cache size divided by what?
Line size.
Line size. What is cache size?
512 KB.
512 KB. What is the cache line size?
64 bytes.
64 byte. Okay. Now we need to explore it further. So if it is 512 kilobytes, so actually it is equal to 2 to the power
19. Yes, sir.
2 to the power
10.
10 and byte, and then 2 to the power 6
Byte.
byte will what?
Cancel out.
Cancel out. 19
Minus 6.
minus 6 is what?
13.
13. Okay, so 2 to the power 13, so it means now it's very tractable. So it is equal to 81 92 cache lines. How many lines can you store in the cache? 81
92.
92. Okay, now if you look at the direct map cache, how many sets will be in the direct map cache?
2 की power 13.
Because it's storing one line, so the number of sets will be. So now the formula is different. So if you say number of cache sets, is equal to number of cache lines, NCL, number of cache lines divided by what?
A.
Number of sets.
Associative, not number of.
Associativity.
So how many number of cache lines?
2 power 13.
2 to the power 13 divided by associative. Now associative is changed. For direct map cache, what is A?
1,
1. For this, A is equal to
8,
8. For this, A is equal to
32.
so it is only the change. The change in associativity implies that now the sets are changing. When the sets are changing, the index fields are changing. Okay. Now, so now, what we now need to find it? Number of cache sets. Number of cache sets. Now, it's done.
Yes, sir. 13.
Now there are three different variants. The first variant is direct map cache. Am I right?
Yes, sir.
So now we want to solve it for a direct map cache. The direct map cache. So what is the number of cache set? Number of cache sets is equal to number of cache lines divided by associativity.
Yes, sir.
What is the number of cache lines?
2 to the power 13.
2 to the power 13. What is the number of associativity? 1. Okay, so it is actually, if you look at here, the number of sets. What is index field?
Index field is
Log 2 of number of
13.
cache sets. Log 2 of 2 to the power 13 and is equal to
13.
13. So what will be the format of the manual block address? 6 bits will be required for the byte field.
Offset, yes, sir.
Index field
13.
13 and tag field
7.
19 and 7. Because the total is 26. We find it using the block size. It is used from how did we get it? From the manual block size.
Yes, sir.
How did we find it?
Cache size.
Cache size.
Not cache size. From the number of
Sets.
cache sets, because it may vary. So it's this index field is a function of
Cache size.
cache size and associativity. Okay? And then the remaining tag field, the remaining bits will be used for the tag field. Now you look at here. Now what was this another example?
8-way associative.
8-way associative. How will it look like? Now, how many number of cache sets? NCL divided by A, 2 to the power 13 divided by
2 power 3.
8, 2 to the power 13 divided by 2 to the power 3 is equal to 2 to the power
10.
10. So how will it look like? How many bits will be required for the byte offset?
6.
6. How many for the index field?
10.
10. And the remaining?
Remaining 10.
10 bits. Now, if you look at for a 16-way, a 32-way,
32-way, yes, sir.
so again, so it means how many number of cache set? Number of cache sets is equal to NCL divided by A to the power 13 divided by 32 to the power 13 divided by 2 to the power 5
2 to the power 8.
2 to the power 8. So how will it look like?
6.
6,
8.
8,
12.
Okay, now what from this observation? So if you look at this observation, so if we increase the associativity, so the number of bits required for the tag field increases,
And the number of comparison we also
and the number of comparison will increase. So it means now we have two types of arrays. One is the tag array and another is the data array. Now we have two types of arrays. One is the tag array and another is a data array. Okay, now I'll rub it off. Now if you look at here, now we have some in general talking about. We are general talking about. So now let's say we have some set 0, now some set 1, set 2, and in the last we have set s minus 1. What is s?
Number of sets.
Total number of sets. Okay, now in one thing we also have not only sets but we also have some set I. Who will determine I? Which field?
Index.
I will be determined by which field?
Index field.
By index field. Now if you look within a set I, so now we have, for this set I, we can have then this addition fields. The addition fields are, we have then four different fields. One is V bit. Why V bit is required?
Valid है कि नहीं?
The data is valid or?
No.
No. We also have dirty field. What is this dirty stand for? Dirty. Yes, if the value has been changed
Or not.
in the cache or not. So dirty field. And we have then a tag field. Okay, so now if you look at this set I, for this set I, now we have different, and now not only the tag field, but also then we have a data field. What is the size of the data field?
Cache.
What is the size of the data field? Data.
Cache line का जितना.
Because it's a memory block. Actually, this is block size. Block size or cache line size. Am I right?
Yes, yes.
What is the block size here?
64 bytes.
What is the size of this V bit?
V
One.
valid 1.
What is the size of the dirty? 1 bit. Now, what is the size of this tag?
Depend करता है कि कौन सा cache है. Direct में.
The tag depends on the associativity. So here the tag field is 7. The tag field is
10 and 30.
10 and then
12.
12. Okay, now if you look at this set I, so now we have, can we write it like this? Cache line 0. Then cache line what?
1.
1. Up to what? Cache line what?
कौन सी associativity है सर?
Journal.
CLA minus 1.
A minus 1. If you look at a particular set, each set consists of how many ways? A ways. So actually, if you look at this set, so each set consists of
A way.
A ways. So now this is now we are looking at set I. Set I is further divided. If you look at set I, so set I is further divided into A cache lines. So set I. So if you look at set I, so set I further divided into
Cache like this.
cache line 0, cache line 1, cache line k minus 1, cache line k, And cache line
A minus 1.
A minus 1. If you look at this cache line K, it is further divided into what?
Bytes.
No.
Words.
V,
Yes, sir.
V, then
Dirty
D.
bit.
and then what?
Tag.
Tag field and then
Cache line data.
data field. What is the size of this data field?
64 bytes.
So this is 64 byte in this example. D is 1 bit and V is
1 bit.
1. And now we have a tag field. Okay, now for the data field, this data field and this field will be same. What's the difference in which? What's the difference
Tag.
between direct map cache, 8-way interleaved associativity?
Tag में और tag में.
Tag. What is the tag size here?
7.
7. For direct map cache it will be 7.
Seven.
And there will be only one cache line. For 8-way cache associative cache, how many lines will be there?
So the set on double
8 lines. For 8-way. For 32-way?
32.
Like. Okay, no, for A-way, if we talking in general, for A-way cache, how many comparisons will be required?
A
A comparison. So for A-way cache, so we need A
Comparisons.
comparison. It's not only the number of comparisons are increased, but the number of bits for comparison are also increased. Because, okay, now if we divide it into three parts. So for 8-way,